just about to fire up the next group of sessions for the WebXR Developer Summit. I hope you had a good break. Next on the ticket is Walid from MetaVRSe. And hello, welcome.
Hi.
And Walid, I will leave it to you. Take it away.
All right. Hi, everybody. My name is Walid Abdelaty, and I'm the Chief Technology Officer at MetaVRSe. Today, I'm very excited to discuss a little bit about the MetaVRSe engine and how we utilize the WebXR hit test. But before I start, I would like to thank the organizers, the sponsors, the volunteers, and everybody involved in making this conference happen. All right, let's get into the editor. So the MetaVRSe platform is a no-code, low-code, drag-and-drop system to easily curate and publish 3D experiences. I'll be touching on some of these topics, as well as diving into the more code scenario for all the devs out there. So let me create a new Web Xor template. Now, our platform looks familiar. You've probably seen this in a style like Unity or other applications. We've got our scene, our assets, our inspector, and this template out of the box comes with a few built-in stuff, which is really cool. We have our AR marker. We have a button that will engage the marker. We have some configurations when it's on and off. And out of the box, anything you put into this project will work in WebXR. Let me put something in here quickly, just so you can see what it looks like when you add objects in here. Let me make this a little thinner. By default, our system works with PBR. So we have an actual PBR skybox in here. If you wanted to see how that looks, every item in here by default has the ability for PBR. So you can mess with that. Let me add a video in here. Let's just make this a little nicer. Let's add our favorite bunny, Big Buck Bunny. Let's make sure this guy's working. Great. Now let's add this video to this mesh. Put them into the albedo. Let's make sure everything's still working. And let's publish. And that's it. WebXR works right out of the box like that. It is magic. No, it's not magic. It's APIs. Let's look a little bit underneath the hood on how this works. So as I was saying, we do WebXR out of the box, but obviously when we're saying no code, low code, there is code. And the way we actually do the code is very straightforward. We've got a world controller that is connected as the central point in the system. So if you were to go into the JavaScript folder that comes right with this template, you'll see that we have a few controllers that are engaged. AR world controller is our entry point. So before I get into what we've organized here, you have access to our entire pipeline. We've got some custom props here, but what comes default are your initialization, the render pipelines, the mouse events, scroll events, touch events, surface events, all sorts of pipeline access. So what you can do in here is that you can override it. And this is exactly what we did to get WebXR working. So off the bat, what we've done is we've organized the WebXR session, the reference space, the viewer space, the hit test source. And we always want to make sure that XR is supported. So the first thing we do is we detect, is XR supported? And then when the session started, we add in our GL layers, our hit test source, and then this is how we actually run our animation frames. One of the key things for us is that we like to have our system developed in both VR and AR. So this will work for both VR and AR. It's not exclusively VR. It's not exclusively AR or XR. Now, how does this all work? Well, when that button that I showed earlier is engaged, it actually calls a function in here that changes our state from main to AR. And then when the render pipeline comes involved, go down to it, our render pipeline, we block out everything. So we actually hijack our renderer and we let the XR session run. Well, how does that work? Well, once you're engaged once you toggle the WebXR, the first thing we do is we request the session, or we end it, and we're using the hit test and our canvas as our overlay. Once that is connected, the XR frame session starts to run. Now, what are these web APIs that we're connected to? Well, the web APIs, the WebXR APIs that we're connected to allow us to actually get the camera information, and our system works directly with it. So as the frames are running, we take directly from the camera the projection matrix and stick it into our camera. Then we determine to see if there's any hit results, and if there are, we capture it. However, when we first engage the XR session, there is no AR anchor. So we have to go through a bit of instructions. So we have to hide everything in the scene. We show the instructions, and we hide the marker as well. And as it's looping, and as you're looking for a plane on the hit test, you'll eventually get an anchor. When the anchor is captured, we then move you to the next step, which is to show the marker. So we hide the instructions, we show the marker, and we hide everything else. And then when you tap the screen, we choose that marker, and then we show everything else in the scene. Now, when we say low code, we mean low code because you don't really need to do anything out of the box, but what we have is access directly to our render session, to the WebXR APIs. You can do anything you would like. Now, one of the interesting things about this is that you can easily integrate any other APIs in here because we are running everything in JavaScript. So let me do one more interesting import. Let's put in somebody to actually watch this video, this big button. Let's put this robot in here. All right, let's get this robot out of the way. Let's just let this get upload. Let's open up this robot. Let's drag the robot in. Let's move some things around here. Let's get this guy up. What I'm going to show you guys here is that because we do PBR directly, we can use PBR maps directly. So in here, you can see that we've got access to all the standard PBR pipelines out of the box. You don't need to worry about how it's connected. You don't need to code anything. However, you do have access to doing your own code, as I was showing you. So the world controller gives you the ability to do that. And then the object controllers give you the ability to connect these pieces. Let's get the silencer in here. Let's get the R channel for the opacity map. All right, we got ourselves a robot. This robot can be watching this screen. There we go. Let me publish this. And there you go. Our system is already updated with the new robot and works directly in WebXR. If you would like to take a ride with this, I'll leave this on for a few more seconds. But this is generally how we like to handle our projects. You've got the 3D environment that you can easily manipulate items into, organize your scene, and then if you would like, you can go ahead and add more control by programming in JavaScript using any APIs you'd like. We do have some helpers that we've added into the project, but as you can see, WebXR plugs directly into our system. So any other type of API for the WebXR system can be attached to our system. So go ahead, go to engine.metaverse.com, register for a free account, and start using the WebXR template and show us what you can do. Thank you, everybody.
Great. Thank you so much. Yeah, I love seeing the fact that all of the sort of low-level work on all these APIs and all of the maturation of the 2D web, and libraries like React and sort of our capabilities as a whole have come to a point where we can build these rich, full-featured editors where people can create these experiences without a lot of code. You mentioned, that people may have seen this sort of editing in native applications before. What were some of the inspirations specifically for the UI and the developer workflows that you use to put this together?
Well, some of the bigger players in the market, like a Unity or an Unreal, they've obviously established design flows for a very long time. So we didn't want to break from that too much, but what our main goal was to be on the web. So one of the ideas was, how do we get such a mature product working on the web the way people are expecting it to work? So we stuck with the standard flow of where things are and the standard scene graph concepts. And what we did was we wanted to make it as easy as possible. So when we say no code, low code, we mean that, because we've got the ability to have it very visually pleasing, and you can set up a scene, have scene decision trees. We've actually got a really cool part of our system, which is configurations out of the box. We can visualize the decision trees and things like that. But as you can see, things that we don't normally present is the actual amount of code that goes into the system. There's plenty of code. So if you are a developer, you can override everything. You can redo everything. You can mess with the GL layer. You can do whatever you would like. We obviously don't recommend that if you want stability, but
Sure.
you have the ability to. So a lot of people get scared from, oh, no code, low code, we're stuck. We're stuck with a system that doesn't allow us to do much. No, it's no code, low code from a curation perspective. But if you would like, you can get a plugin, and a plugin can actually help augment the editor. So then, there's a piece of code, and again, this is inspiration from Unity. There's a piece of code that interacts with our inspector. So this code could do many fancy things, but from the end user on our platform, they're only sliding some little slider, right? So we're very much allowing, the full swath of code, but we try to keep it as simple as possible, because at the end of the day, our need for this product was to simplify the development cycle that we've been having with our customers and what we've been doing. So this is sort of what we hear from our customers. How do we simplify the process? And how do we make it so when you press publish, it updates? We're focused on making the web and 3D work together, because people make web pages, they expect you press a button, it updates. Well, why can't 3D be that way? And our platform allows you to be able to easily just go in, do what you'd like, get as advanced as you'd like, or use the simple plugins that we have, the simple visual tools, and then press publish. And that's it.
Are there things that you would ask for, sort of high-level features or functionality that is holding you back right now, that you feel like you need from either the specification community or from the browser implementers?
I've been watching all day. There's a common thread, and that common thread is, first of all, stability in the drafts, right? I feel like there are a couple of things that changed over time. Part of why we didn't immediately jump on WebXR, especially because the WebVR, it all changed, and it was dramatic, but we weren't there. We were working with it, but that started to stabilize, and then you can see that we're starting to put this as part of our platform, because we know that this is going to stay stable. Now the other challenge is iOS. Now we've managed to get iOS working, but when it comes to WebXR, as everybody has pointed out, is a bit of a challenge. And there are companies doing things to try to utilize the single-threaded environment, but again, we know there's only so much horsepower you can pump out of the browser. So having WebXR natively available takes away from people trying to spend too much time on getting just XR working, and they can focus on the project and focus on making something immersive and not a gimmick, and actually get a lot of juice out of the browser. So yeah, it comes down to compliancy and a couple standards. Shared buffer array is a big one for me. We would love to have multi-threading across the board. OpenGL, 2, 3, a little higher, but WebGL is coming out. So, there are some things that are going to be beneficial to the community, our company, everybody in the near future. So as soon as it becomes more stable, we will flip that switch and out of the box have everybody, I didn't mention, we work on every platform. So although we do WebXR, we weren't sure. So we had to make sure that our JavaScript core library, WebAssembly, JavaScript core library works natively as well. So if, no need for native applications, we are more than happy.
Yeah, and that's kind of the theme of the day is right. Let's put it all in the browser and make the browser a good place for this sort of work. So thank you so much for talking to us about it. I think that there's a lot of people in the audience who have never seen that kind of interaction in a browser. So thank you for sharing.